Subscribe our channel, press the bell icon for latest videos.
Hi friends, here in this video we are going to see the formula for stress due to suddenly applied load in case of strain energy. So let's get started. Stress due to suddenly applied load would be explained with the help of a graph. On y-axis we have load, on x-axis there is deflection. Now what is the meaning of suddenly applied load is that first, in case of suppose gradual loading, we want to load a material up to 50 kilonewton. Then in case of gradually applied load, the loading would be from 0 to 50 kilonewton and that would be in steps. That is, the load would not be increased suddenly, but from 0 to 50, this is just an example, the load would be increased slowly, like for example first 5 kilonewton, then 10, then 15, and it will go on increasing up to the maximum value, which is 50 kilonewton. That is for a gradually applied load. But when we have a suddenly applied load, at that time the maximum value, that is 50 kilonewton, is applied suddenly as a whole. So the load increases suddenly. It can be shown onto this graph, like from 0 to maximum it reaches up to a value of P suddenly, and similarly due to the applied load, which is the maximum load, the deflection would also be sudden. And we are getting this area. And this area under the curve, that is under the curve, load and deflection, is nothing but strain energy or the stored energy, also called as resilience. So to derive the formula for stress, I'll write down strain energy is given by since strain energy is area under the curve or area under the graph of load versus deflection, so therefore strain energy denoted by capital U, and the area here is area of a rectangle, which is P into delta L. Then strain energy is given by the formula sigma square into volume, and volume is area into length upon 2E, is equal to, load will remain as it is, deflection is given by the formula stress into L upon Young's modulus, because since deflection is PL upon AE, so this term of P upon A is called as stress. So the formula for deflection is stress into L upon Young's modulus, and strain energy is given by sigma square into volume, which is area into length upon 2E. And how this formula has been derived, for that you all can refer my previous video in which I had explained the concept regarding strain energy. Now from both the sides, E will get cancelled out, the length gets cancelled out, and even one of the stress will go away. So what remains is stress into area upon 2, and onto the right hand side there is P. So I'll keep stress on one side because we need to find the stress for suddenly applied load. So sigma would be on one side, this 2 gets multiplied with P, so it is 2P upon A. The unit is Newton per mm square. Now in case of gradually applied load, the stress is P upon A, and in case of suddenly applied load it is 2P upon A. So we can say that in suddenly applied load the stress is doubled than that in case of gradually applied load. Because in case of gradually applied load the stress is P upon A, and here we are getting 2P upon A. So because of the sudden increase in load there is an increase in stress which is double than that of gradually applied load. So this was regarding the stress due to suddenly applied load. At the end, if you'll find my videos helpful, you can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.